we will be considering a way to use calculus to calculate the volume of a solid. And I think the best mental picture that I have, mental model that I have for these things, is imagine a cylinder. Right, so something like this. And picture, if you will, the cylinder as being, say, a stack of CDs. Now, if this is a stack of CDs, then what you have are stacks of circles with a certain amount of thickness. And each of these circles has an area. And if you could take the area of every single one of these circles, and remember that the area of a circle is pi r squared, then, and added up the area of all of the circles, you would have the volume. Now, the stack of CDs, each CD still has a certain amount of thickness, and so it would be perfect if we could shrink our thickness of the CD down to zero, down to nothing. Alright, so we want the thickness of the CD to go to zero. And so it's ultimately a limit process that we're using, where as the thickness of the CD goes to zero, what we have left is stacks of circles, no thickness. And that means there would be an infinite number of circles. And if this makes sense, then the integral roughly that we use to take the volume of a solid, thinking about it as stacks of circles, is of the form pi r squared for the area of each circle. And we'll say, I guess in this case it would be dr, where this is the area of the circle. Dr represents the thickness of the circle, but it's infinitely small, right? And then we've got an infinite number of circles, right? So this is the form that all of our integrals will take. And so the issue is coming up with an expression for the radius. Once you have an expression for the radius, then the integration can be trivial. Either you'll do it by hand, it'll be something you can do, or more importantly, you'll use your calculator to do it. But the principle is that we can think of a lot of things as stacks of circles, and when we find the area of all of these circles and add them up, we will then know the volume of the object. And the summing of all of those things is really the integration process. Right? A limit of a summation, we're adding up an infinite number of things, is the integral. So that's the principle, and so we will look at some examples of this idea. And again, think through, we're integrating area, which is always units squared, to come up with volume, which is always units cubed. And notice how that's similar to integrating x squared to get something x cubed. So let's consider some examples.